Hey guys, it's Miss Peters, and today I'm going to go over the difference between physical and chemical changes briefly, and then physical and chemical properties, including intensive and extensive. So physical change is something where atoms are not rearranged into a new substance. So let's say in this example, water is boiling. It is H2O liquid before it becomes water, but it's just a gas, but it is still H2O. Same with when you freeze water, it goes from liquid to solid, but it's still H2O. So in a physical change, the chemical formula stays the same. Some other changes that are considered physical changes, phase changes, that's like melting, boiling, changes in size, if you cut something, shred it, chop it in half. Those are all physical changes because it doesn't change the chemical formula. If you change its shape. And dissolving, if you dissolve sugar into water, like you're making iced tea, you stir in sugar, that's a physical change. And there's some more examples: tearing, breaking, smashing, building, and dissolving. A chemical change, however, bonds are broken and new bonds are formed, and you get a new substance. So that would be like to make water. You have H2 plus O2, and then together it forms H2O. And so what happens is this oxygen molecule actually has to break apart, and one oxygen pairs with a molecule of H2. So the chemical formula is now different. It was O2, now it's H2O. Some examples of chemical changes are burning. Anytime you burn something, it's something different. Rusting, decaying, like when you eat food and you digest food, that is a chemical change. When things decay, like in the forest, I don't know, when something dies, it decays, it breaks down, that's a chemical change. It's not the same chemical substance anymore. And so some ways we can tell a chemical change has occurred: if it's exothermic, it will give off heat, feel really hot. If it's endothermic, it actually takes in heat, so it feels cold. Endo, cold; exo, hot. Also, if it produces light, like there's a flash of light, that's a sign of a chemical change. If it produces a gas, that's a chemical change because something new has occurred. And it might be that you see bubbling, you see fizzing, but that's usually a sign of a chemical change. If it forms a precipitate, and so that is a solid that is formed when two liquids are mixed together. We won't see this for a while in chemistry, but if I say you mix two liquids and now there's a solid, that's a chemical change because you made something new. If there's an unexpected color change, the Statue of Liberty is made of copper. It used to be copper, like a penny copper. Well, over time it reacted with air and it formed copper oxide. And so it's now that, which has that blue-green color. Silver, I don't know if your mom or maybe your grandma has like actual nice silver. You have to clean it because it will tarnish and react with the air. And so tarnishing is an example of a chemical change because it's not just silver anymore. It reacts with the oxygen in the air and forms silver oxide and other stuff. Odor changes. When milk sours, that's a sign there's a chemical change going on. Anytime you cook food, that is always a chemical change. It is something different now. Okay, and so chemical physical changes are usually pretty straightforward. Chemical and physical properties are a little more complicated. So physical property can be observed without a chemical change occurring. So if I ever give you something and I ask, is this a chemical or physical property? Well, can you determine that property without doing a chemical reaction? The answer is yes, it's a physical property. So like color, could you determine the color of something without doing a chemical reaction? Yes, you can, because you can look at it and see the color. Versus a chemical property, that can only be observed when a chemical change happens. So to determine if something is flammable or not, if it will light on fire, guess what? You have to try and light it on fire. And when you light something on fire, that's a chemical change. And if it catches on fire, oh, it's flammable. You know that. But you couldn't know that without trying to catch it on fire, which is a chemical change. And then some more examples of physical properties: color, shape, texture, viscosity. Viscosity is like how thick a liquid is. You know, like ketchup can, like, you know, it's very thick. It doesn't flow easily versus water. Buoyancy, how things float. You know, if you throw a ball in water, it floats. Oh, wow, it's buoyant. That's not a chemical change. Chemical properties, flammability, something can rust, anything about reactivity. And then something on chemical properties that a lot of people mess up. If I say something is non-flammable, that is still a chemical property because you had to try and light it on fire to determine that it's not flammable. So that is a property of how it reacts or doesn't react in a chemical reaction. Same with if I say it's not reactive, that is also a chemical property, not a physical, because it's telling you you had to try and react it with stuff. You were attempting a chemical change, but it won't react. So that is actually a property, a chemical property of that matter. Okay, and so physical properties can be broken down into two categories. They can be extensive, which is a physical property that depends on how much matter is being considered. So for example, mass is an extensive property because let's say I have a little beaker and then I have a really big beaker and I fill them both up to the top with water. This beaker of water is going to weigh more because there's more water in the beaker. While this one is going to weigh less. So let's make up masses. Let's say this one is 10 grams of water. And this one is, that one's smaller, so it would be 5 grams of water. They're both water, but they have different masses because they're different sizes. So that is why it's an extensive property. And so I like to think about this example when I'm trying to decide if something's extensive. So let's say I asked you, is volume intensive or extensive? Well, would the volume of the water in these two beakers be different? Yes, it would, because they're different sizes. So that's an extensive property. An intensive property is a property that stays the same or it doesn't depend on how much matter is considered. So with that example of the water in the beakers, it doesn't matter how much or how little water you have. Water is clear. That's an intensive property. Its color, it's clear, doesn't change whether you have a lot or a little. Something else that would stay the same is water's boiling point. Water is going to become a gas at 100 degrees Celsius, whether it's the big beaker or it's the small beaker. So boiling point is an intensive property because it stays, that is true whether you have a lot of water or a little water. It's always 100 degrees Celsius. And so we're going to go through some examples and try to decide if these physical properties are intensive or extensive. So the first one, volume of coffee in a mug. Well, let's think about it. I could have a really small mug, like a tall at Starbucks, or I could get a grande. Are they going to have different volumes of coffee? Yes, they will. So that's an extensive property. Number 2, and this one's kind of tricky, percent of sugar in a Coke. So let's say you go and we look at a can of Coke and we read the ingredients. And then we go and we look at a liter of Coke and we read the ingredients. They are the same stuff, so they actually should have the same percent of sugar. So that is an intensive property. That's kind of a mean one. Number 3, the number of calories from a banana. Well, if you've ever looked into nutrition, calories depend on how much you're eating. So if you eat a really small banana versus a really big banana, the big banana will have more calories than the small one. So that would be an extensive property. I'll erase my banana. And then the melting point of ice. So all ice melts at 0 degrees Celsius. That's when it goes to a liquid. And that doesn't matter if it's an ice cube or an iceberg. Ice melts at 0 degrees Celsius. And so that is an intensive property because it's the same whether it's an ice cube or an iceberg. And then we're just going to go through a few more examples. This one we're going to decide if it's a physical or chemical property. And then if it's physical, we're going to label it as intensive if it's chemical, or extensive if it's physical. Okay, so the silver spoon tarnished and turned black. Tarnishing is a chemical property, so I'm just going to put a C by that one because that's chemical. Baking soda reacts with vinegar. Because I said reacts, that should give you hint, hint, hint. That's a chemical property. A sheet of copper can be pounded into a bowl. If I turn a sheet into a bowl, I'm changing its shape. So that's a physical property. And then let's decide, is it intensive or is it extensive? So let's say I have a sheet of copper this big and a sheet of copper this big. Could I change the shape of both of them into a bowl? Yes, I can. They might not look like the same bowl, but I can change the shape of both of them. So that is an intensive property. Oxygen is an odorless gas at room temperature. Does it require a chemical reaction for you to smell something? No, when you smell, you're not changing the oxygen, you're just smelling it. So that's a physical property. And then oxygen is odorless. That is true whether it's just a little bit of oxygen or if you're breathing from an oxygen tank and you're getting a lot of oxygen. So that's an intensive property. Barium melts at 725 degrees Celsius. Melting is a physical change. So that's a physical property. And then we talked about melting and boiling point already. All barium melts at 725, whether it's a lot or it's a little. So that's an intensive property. The volume of the ball is 400 centimeters cubed. Well, I can tell volume without a chemical reaction, so that's a physical property. And then, is every ball that ever exists have a volume of 400 centimeters cubed? Tennis ball, football, basketball? No, they all have different volumes, so that's an extensive property. Helium does not react with any other element. That one, that keyword react. I'm saying it doesn't react, but it's still about the way helium does or does not chemically react, so that's a chemical property. Copper turns green when exposed to the environment. That is a chemical change. We talked about that with the Statue of Liberty. It's an unexpected color change. You wouldn't expect copper actually turns green when exposed to air, but it does. So that's a chemical change, and it's a chemical property. And then you might want to pause the video and see if you can do these yourself, but I'm going to go over them. Okay, so mass of the NaCl sample is 30 grams. Mass is a physical property, and is every sodium chloride 30 grams? No, depends on the size of your sample, so that is extensive. Alka-seltzer tablets react with water to produce gas. React, it's a chemical property. Diamonds are a very hard substance. Well, you can tell diamonds are hard by touching them. That's not a chemical change. So that's a physical property. And then let's think about the next part, intensive or extensive. If I have a diamond that size, or if I have a big old rock, are they both really hard? Yes, they are. All diamonds are hard to the touch, no matter the size. So that is an intensive property. Gold is non-flammable. Well, if I change that and I said gold is flammable, you should easily say chemical property. So non-flammable, it's still a chemical property. Acid in tomato sauce can corrode aluminum foil. Corrosion is a chemical change, so that's a chemical property. And then the dog weighs 64 pounds. Well, mass or weight is a physical property. And then maybe your dog weighs 64 pounds, but my dog Skittles weighs 14 pounds. So that's not true for every dog. So that is an extensive property. So for this one, I want you to pause the video and see if you can try these on your own. I'm going to go through and highlight the answers now. And I'm not going to talk about all of them for the sake of the time of this video, but I will talk about a few. Conducting electricity is actually a physical change. Think about your light bulbs. They're not permanently changed every time they conduct electricity. And that is an intensive property because small pieces of metal can conduct electricity. Big pieces can too. Same with copper. Ductile is how stretchy something is. Like you can stretch out a piece of copper. Malleable means you can change the shape of it. So that would be like that example we talked about. You can change the shape of a small piece of copper. You can change the shape of a big piece of copper. And that last one would be intensive because if it's a big bar of lead or a small bar of lead, it still bends easier than any size of aluminum. And then here is a little flow chart. If you're struggling and you're like, you need help, follow this flow chart. And that's all.